We're going to derive quadratic equations given certain attributes of those equations. So we'll start this first one. We have a point, 6, -1, and a vertex, 4, -3. So we're going to use vertex form since they gave us a vertex. So here we go with our vertex form. Now the 6, -1, that's just going to be an x and a y that I put into my equation. And the 4, -3, since that's the vertex, that's hk. We are going to solve for the value of a, and then we'll have an equation. But we have to find a first. So we're just going to take what we know, plug it in, solve for a. So y is -1, a is my unknown, x is 6, h is 4, and k is -3. So we're just going to solve it. Add 3 to both sides. And then 6 minus 4 is 2 squared. So when I divide both sides by 4, I get 1/2. A is 1/2. So I'm going to take that piece of information, plug it in for A and my vertex, and we have an equation. 1/2 x minus 4 squared minus 3, not k. We want the actual number there. And that's all you have to do. Let's do another one. They gave me a point, xy. My vertex is hk. Let's do it again. -3 equals a, x was 5. 5 minus 3 squared plus 5. Subtract 5 from both sides. 5 minus 3 is 2. 2 squared is 4. Divide both sides by 4. And a is -2. So we'll plug that into our equation. -2. My vertex was 3, 5. Just make sure you put it into a quadratic equation, and you've got your squared right there. So number 3 is the exact same thing, a point and a vertex. So I'm just labeling mine so it helps me when I substitute. Y, 0 equals a, I don't know, x is 1, minus -2. So 1 minus -2 is, of course, going to become plus 2, minus 9. Add 9 to both sides. 1 plus 2 is 3. 3 squared is 9. So it looks like a is 1. So y equals, now I don't have to put a 1 in front of my parentheses there because it's understood to be 1. That's a minus 9. But if you put a 1 there, we'll just kind of go, whatever. But you don't have to put the 1 there. All right, let's change things up a little bit. This time they've given me a point. I'm still going to call that xy, but they gave me the x-intercepts. Now the x-intercepts could also be referred to as the roots or the solutions. In this particular situation, I'm going to use them as the roots, and I'm going to use factored form this time. On the first three, we used vertex form because they gave us a vertex. But now since they gave me the roots, I'm going to use factored form. It's x minus r1 and x minus r2. So we'll plug our numbers in. Y equals, a is still my unknown, x is -4, minus root 1, -7. So that's, of course, plus 7. -4 minus 5. And now we just solve for a. -9 equals. -4 plus 7 is 3. -4 minus 5 is -9. So -9 equals a times -27. So I will divide both sides by -27 and find out that a is positive 1/3. So now all I have to do is go back to my original and put 1/3 in for a, and then my roots, x plus 7x minus 5. And that is my equation in factored form. Okay. Number 5, similar question. We have a point, xy, but we only have one intercept. So when you only have one x-intercept, that means that your graph is either this or this. But I only have the one. So 2 is going to count as root 1 and root 2 because there's only one. It's the same thing. So we're going to do the same thing, but for R1 and R2, we're just going to use the 2. So y equals a times x is 0. 0 minus 2, 0 minus 2. And we will find out that a, I think, might be 3. Oops. Let's go with negative 3. Negative 2 times negative 2 was positive 4. So a is negative 3, so it's actually this one pointing down. So when I put it into my equation, y equals a, and then 2 is my only intercept, so I just count it twice. Or if you notice and you want to do this, you can do x minus 2 squared. When you look at the second one, you can see that, well, first of all, it's a reflection over the x-axis. And the vertex would be at 2, 0, right here, going down. Interesting. All right. Now, this one's a little bit of a doozy, so sharpen your pencil if you need to. This time we're going to write an equation that contains these 3 points. Well, we can't use vertex. We don't know the vertex. We don't know the x-intercepts. We do know the y-intercept because it gave me 0, 9. So in this one, we're going to use standard form, and we're going to have to put our little thinking caps on. So standard form, remember, was y equals ax squared plus bx plus c. Move this way. So we're going to do an equation for each of these. We're going to end up with 3 equations. So this one, y is 12 equals ax squared. So negative 3 squared times a plus bx, negative 3 times b, plus c. I don't know anything about c. So that's going to end up being 12 equals 9a minus 3b plus c. All right, the next equation, the 0 and the 9. Y equals, this one's a little bit easier because 0 squared times a plus 0 times b plus c is going to give me 9 equals c. So that was really nice of them to give us one like that. The c value is 9, and that'll make the rest of our work easier. Let's go to the third equation. 24 equals a times 3 squared plus b times 3 plus c. Now that we know what c is, this will get easier. 24 equals 9a plus 3b plus c. So notice we have a system of 3 equations, and we're going to do some substitution and some solving. The fact that we know that 9 is c is really helpful because now I have 12 equals 9a minus 3b plus 9. And I have 24 equals 9a plus 3b plus 9. So I have 2 equations with 2 variables. And I'm noticing that these are already opposites. So I don't have to do a whole lot of work to do my elimination. Let's add these together. 36 equals 18a, negative 3b plus 3b cancels, plus 18. 9 plus 9. When I subtract the 18 from both sides, I think A equals 1. Now I know A, I know C. I'm going to go solve for B. So let's just go back to the first one. We'll say 12 equals 9A minus 3B, that's the one I don't know, plus C. And now we solve. I've got 9 plus 9 is 18, so I'm going to subtract 18 from both sides. Negative 6 equals negative 3B, so B must be 2. So I can go back and write my equation. I know A, B, and C. Y equals, A was 1, so I don't have to put it there. B is 2, C is 9. There is the quadratic equation that those 3 points go through, or that goes through those 3 points. It contains them. So it's a little bit of work, but we can do it. Okay, the last one's just a review, a refresher. Let's rewrite this equation into standard form. So we want to make it say ax squared plus bx plus c. My preference, you could distribute the 3 first, but only distribute it once. I'm going to FOIL here in the back, and then I'm going to distribute my 3 at the end. So this is what mine looks like. 3. 5x times 2x is 10x squared. 5x times negative 1. 2 times 2x, and 2 times negative 1. I'm going to combine these to be negative x, and then I'll distribute my 3. 30x squared minus 3x minus 6. Here's my equation in standard form that matches that equation.